Swayam Prabha. Digital India. Educated India.
Welcome back to all my students and people who are taking this course. I am sure everybody is fine and enjoying this course of project management. So, this is the 18th lecture, and as I discussed in the last few minutes for the 17th one, I will try to wrap up utility analysis and the concept in the 18th one, and then again start off using these concepts which I just would be wrapping up in the utility analysis in the area of project management. As we have been continuing, we have been discussing the concept of expected value of a decision, what is a fair gamble, how people are risk averse, risk loving, risk neutral. Then we considered certainty value, then we tried to use the general concept that how you can find out the utility function of a human being. Then we went into mean variance concept, how it makes sense considering the utility function is quadratic and its relevance to normal distribution. Then we went into geometric mean concept, and we will continue that. We had other concept like safety first principle, we will consider that as we progress with this 18th lecture. Maximizing the, I will just mention few important points without going to the theory, just for the interest of the people who are taking this course. Maximizing geometric return is equivalent to maximizing the expected value of log utility function. So, for mean variance and quadratic utility function, it makes sense, while for geometric return and the log utility function, they make sense. That means, one to one correspondence is there between these two concepts separately. Projects, investment portfolios that maximize the geometric mean return are also mean variance efficient. So, this is I will just discuss in 2 or 3 bullet points. Also mean variance efficient if returns are log normally distributed. So, in case returns are for the prices of the stocks, prices of the investments are log normally distributed, then the mean variance efficient of the if the returns are considered, then the using that concept, the ranking or the best policy which we get for any project, any investment, any decision also comes out to be true if you are considering the concept of geometric mean return. So, I am just mentioning is as important points, not to be dealt in the theoretical framework, but more from the practical point of view to try to understand. Now, we come to the next concept, which was the safety first principle. Under safety first principle, the basic tenet is that the decision maker is unable or unwilling to consider the utility theorem or the concepts to make his or her decision process. Under this methodology, people make the decision placing more importance to bad outcomes. That means, we always consider people are negatively inclined and they want to base their situation based on the fact that the negative outcomes are coming out to be more true. So, you are always playing it is very safe for you, loss is of more importance and if profit is there, you are happy, but not to that extent in the relative scale that if you make a loss you are much more sad. So, 10 rupees profit if you make with respect to that a loss of 10 rupees which you make, the consequence for your decision is more affected by the negative movement of the prices, that is minus 10 the loss. So, generally we will consider that in a very simple theoretical framework and the quantity model. So, that what we mentioned is basically the concept of safety first principle. So, safety first principle has different formulations. So, I will just write down these formulations and you will understand that how they make sense. The first one is that you try to minimize P is the probability, I try to minimize the probability that the value of the so called portfolio of the projects which you have is less than some RL. RL is basically some fixed value which you have set for yourself. Consider you are making a decision, you are making an investment, you are making a project, you are planning a project and you want to invest some money, there you will consider that the total amount of the project should definitely be as low as, say for example 20%, not less than that. So, you will try to minimize the such chances that the return on the project does not follow below that overall percentage which you have set for yourself. So, as these are non-deterministic processes, the returns are changing. Obviously, they would be, if you simulate them or see them or basically have a look at how things are happening, there would be chances or there would be some instances where the value of the so called project portfolio which you have is less than RL, but you want to minimize such occurrences. Other one is basically you want to maximize RL, that means the return based on which you are trying to analyze your portfolio. So, higher it is, that means if I consider the real line, on to my left are the negative values, on to the right are the positive values. So, I want to push it as high as possible on to the right. And another one is basically trying to maximize the average return of the portfolio, considering that the combinations of the portfolio for the project can be changed according to the weights you are trying to invest. Say for example, there may be instances you want to invest 10% of your total money in activity 1 or project 1, and similarly based on that you take a decision. So, if returns are normally distributed, then the optimal portfolio for the project would be the one where RL was the maximum number of times standard deviation away from the mean. So, how many number of times it is away either onto the right or to the left of the standard deviation, which is sigma, is of more importance to us. So, let us consider an example. We try to minimize the RP value, which is the portfolio for the project being less than equal to less than some RL value. Remember that we consider the returns are normally distributed, that means we are considering the constant of utility function being quadratic, and the suffix p as I mentioned denotes the portfolio, while RL means the fixed return and depending on overall scenario. So, in our case consider it is 5. So, for instances A, B, C are the instances of different examples. The RP values for A, so technically it is RP comma A is given as 10%, RP comma B is given as 14%, similarly for C it is given as RP comma C as 17%. The standard deviations for A, B, C are given as 5, 4, 8, and if I find out the differences from 5%, which is the RL value, they are given as, it is basically minus 1 sigma A, that means on to the left, minus 2.25 sigma B on to the left, and minus 1.5 sigma C B on to the left. So, basically if you want to minimize, then you find out that what is the minimum value, because you want to minimize them, minimum probability such that is on to the left. Now, remember here there may be some instances where you need to normalize. So, why I am raising that concept is that as I have been talking, many of you may have been thinking that, well, the returns and standard deviations are given, is not it right? The question would definitely be asked by all of you, is not it right that if we normalize them and bring the concept of standard normal distribution into the picture, hence ranking is much better. So, that can also be done, we will consider that later on. So, in this case the differences, as I am again mentioning, from 5% which was RL are given, based on that you take your decision, because as your main motive is basically to minimize according to the safety first principle concept. So, there were 3 concepts under safety first principle, we are taking the first one. So, now if I draw the diagram it will make sense. So, consider normal distribution as I had mentioned, and along the x axis the returns are being plotted. So, you have basically R bar A, R bar B, they would be R bar C and such set of portfolios for projects. And what I have drawn is basically the return distribution for the dark black one is basically for A. So, this is the average value of A, and this is the standard deviation. So, this 2 sigma means I am going plus sigma onto the right, minus sigma onto the left, considering the sign means moving to the left with the negative. Again this is the average value of B, This dotted one is for the return distribution for the portfolio of project for B, and this again if I move from the average value on to the right, this is the quantum of movement, and if I move to the right, this is the quantum of movement. Similarly, if I have C, I can draw the graph. So, what is now important is to note that what is RL. Consider RL I have fixed here, which is the red one. So, I want to find out that what is the probability of such occurrences of the difference being less than RL. So, if I consider the black normal distribution which is for A, then actually what I am interested to find out is first this probability, which I am marking using yellow one. And if I basically go for the B, what I am interested to find out is this one. So, it will continue till infinity exponentially. So, I want to minimize the overall area coverage, that means I want to basically minimize the probability in the very simple sense. So, less the probability better, more the probability on the negative sense onto the left is definitely not a decision to be taken. In order to determine how many standard deviations RL lies below the mean, we consider RL minus the mean divided by the standard deviation. That means, the question which I did ask to all of you in the last to last slide, whether it should be normalized, is actually true. So, if I want to basically find out this normalized mean, so what I do is very simply this. I find out that what is basically the difference of RL value with respect to the portfolio of the project divided by sigma p, which is for that project, or else you can maximize. So, minimizing the RL minus RP is also equal to maximizing the difference. So, this is equivalent to the formula which is basically given here. Now, if you see what I am trying to do, I am trying to basically bring a semblance or conceptual linkage between the RL value and the RF value. RF value is the risk free interest rate. So, in one of the problems or in the problems we have already been discussing RF, which was small r, because the return was calculated by I suffix 1 minus I suffix 0 divided by I 0. So, here capital R is calculated according to the formula which I have written down twice. So, I am sure it is clear to you all. So, what I want to find out is basically the difference between RP and RL, or RP and RF, and normalized by the standard deviation, and if I am able to minimize this, it also means that I am able to maximize and get the same answer. So, it is basically simple concept of using the standard normal distribution in order to solve the problem. Even though for our example we have simplified assumption by considering only the normal distribution, but this will hold true for any distribution having the first and the second moment. Now, here I will just pause and give you the concept, like just give in a qualitative sense the concept of different inequalities which are used in statistics, and I will just discuss one of them, how it makes sense in order to bring that or those type of inequalities in the decision making project for a portfolio, for a decision, for a project or a set of projects, whatever it is. So, first let us consider the Chebyshev's inequality. So, consider this inequality is true with these assumptions. There is a random variable x such that the expected value and the variance of x exist. It does not mention anything about the distribution. Then we know again this RP is probability. So, the difference between x minus the expected value divided by the standard deviation or the square root of the variance being greater than some t value, t is some fixed value which you have set for yourself, is equivalent to 1 by t, less than equal to 1 by t square. So, if you go to statistics, you will understand the overall implication of Chebyshev's inequality. So, what we are doing it in this problem is that we are trying to basically convert the Chebyshev's inequality in this concept of a portfolio decision making process, where rather than basically take t, we take the value of k and then try to find out the concept here. So, if you note down here, what we are doing is that in the initial case we considered RL as the cutoff or RF as an equivalence to RL. So, now RF as an equivalence to RL, sorry. And here what we are doing is that we are trying to find out the difference between RP for the portfolio with its mean value and then normalized considering the standard deviation is used as the denominator to divide it and then make it on a normalized scale. So, if I consider that, I consider the mode of that, I basically take RF minus RP bar and divide by standard deviation if it is greater than T with some probability, and that should be greater than less than equal to 1 by k square. So, if I have that and if this k value is given, I can find out that using Chebyshev's inequality I can also rank different type of projects accordingly. So, this concepts of trying to normalize them using the standard normal distribution or using the concept of Chebyshev's inequality where the first moment and the second moment exist without considering anything about the distributions, they can be utilized in a very big way and very conceptually such that we get good interesting results for the case of portfolio for the projects. So, as we are interested to consider the continuation of Chebyshev's inequality, as we are interested in lower limits, hence we simply simplify it and we have this formula. So, what I am doing is that I am trying to basically normalize them. So, if I consider this RP minus RP bar, so I am considering this k value as putting it like this. So, this is a normalized value. So, RL minus RP whatever we have considered. So, RP or RF whatever it is. So, I am normalized RP value with respect to its mean value and standard deviation. I have normalized RL value with respect to the mean of the portfolio of the project with its the portfolio's standard deviation. So, this value comes out to be less than equal to sigma square p for that particular portfolio of project divided by the differences. So, if you see this formula, this is exactly what we needed, where all the standard deviations and the return of the portfolios of the projects are given or risk free interest is given whatever is there or RL is given as the case may be, and then we find out these differences of the probabilities and find out the values and rank them on from the highest to the lowest or the lowest to the highest, and then take the according values such that we are able to get the best so called portfolio of projects considering the safety first principle. The right hand side of the inequality is exactly equal to the decision process number 1 under safety first principle, because we have considered previously this. Let me again go back here. So, in this project is exactly this less than equal to sign or greater than equal to sign does not make sense, because it is just 1 minus or without the 1 minus, and we basically solve the problem. So, what we have here is the probability. So, what we can do is again if you find out this PR is the probability RP minus RP bar by standard deviation less than equal to or less than whatever it is RL or RF as it is, and you can find it using the standard normal table and solve it accordingly. I will solve 1 or 2 very simple problems later on. For the second criteria, we are basically maximize RL. The first one was the probability finding out the difference between two values less than that, such that we have under the condition the probability of RP being less than equal to RL is some alpha. So, alpha value is given, we want to find out the maximum value of RL such that the probability value is already met. So, say for example, we have the value of alpha as from the table as 0.05 which is 5%, then we have this value again using the standard normal distribution. This is the value of alpha, and if you have the distribution as given, this is the mean value, this alpha value is given, then you can find out accordingly that what is the second concept of safety first principle, how it can be utilized to find the rank of the projects for the portfolios. So, again this value, this alpha being on to the left or the right does not make any difference, because I am just trying to give you a feel that how this problem can be solved. So, if you see the distribution which is the standard normal now, because I have converted into a standard normal, this R bar B is the average value. So, in the standard normal case it would be 0, but I am just trying to denote it using R bar B for the understanding of the students. So, alpha value is given. So, alpha value being given, that means I want to minimize this, given this I want to basically pull up RL as far as to the right. So, better it is if it is onto the right. So, I will basically rank them from the highest to the lowest and to choose the basic value as given. See, the other case we consider this value of R p with respect to sigma p. So, if you see the y axis and the x axis, it makes sense in the way that the concept of risk return framework from the mean variance concept is being used here. So, consider the parallel lines which are there, which are inclined, and they have the values of R L comma 4, R L comma 3, R L comma 2, R L comma 1. So, these are different values of R L. So, what I want to do is that consider the efficient frontier is this line which the curve which is given, and I want to find out that set of project portfolios which basically gives me the maximum return. So, how do I do that? So, this R L value I want to maximize. So, as per the concept of safety first principle, I want to basically maximize a certain value with respect to the R L, because R Ps are the return of the projects. So, consider R L some arbitrary value here. So, what I do is that I start pushing it parallelly. So, this is the arrow which basically gives it moves parallelly. The moment the tangent, it forms a tangent at a certain point for the overall efficient portfolio, that value would give me the best combination of R p and sigma p such that this R L is the maximum value based on which I am able to attend that particular set of project portfolios. So, it is basically a schematic way of trying to make you understand. Obviously, there are optimization problems based on which we can use it. So, what we do is that fix the efficient frontier and start increasing the value of R L such that it is a tangent at certain point considered is P star. So, at that P star I find out R p bar and sigma p, and also find out the value of R L 3 in this case, such that this R L 3 is the value of R L such that is basically follows the concept of safety first principle and gives me the best results such that I am able to get the portfolio of the project which has the criteria based on which I am trying to work, which is the safety first principle. The criteria for the last one is maximize R bar p such that again this such that condition remains the same. So, this R p being less than equal to R L, as I have considered in the graph here, if in the last to last graph this was alpha, this is exactly the same. So, this value is basically R bar p, whatever the portfolio of the project is, and what I need to do is that I would need to basically push this mean value as far as possible to the right, provided this probability remains the same as alpha. So, is this alpha value is the level of risk I am able to sustain for my overall project. So, here alpha is determined depending on the investor's own constraints or for the project. Thus, from the condition you will basically have this. So, this means that R p is pushed here. So, R L which is basically here is some standard deviation here. This standard deviation, if it is 1, it means that it is plus minus 1 onto the right and to the left. It is 4 standard deviation, it means it is plus 2 onto the right and minus 2 to the left. So, this z value would give me how many values of standard deviation that value of R L is onto the left or R p such that we are able to take the decisions accordingly. So, if I am able to maximize R p, that means I will try to push R p as far as to the right. So, the value of z which we see here, so R p I am trying to increase, sigma p value is basically standard deviation which is given, and we will consider this is fixed, because if we keep changing sigma p also, then it become a bi-objective problem. So, I am only trying to basically maximize one objective which is R bar p based on the fact this is alpha. So, as it increases, the difference increases, and I want to find out that value of z which is maximum and take my decisions accordingly for the safety first principle, which is the third criteria. So, what we did was basically we considered the concept of safety first principle from the concept of maximizing the probability or minimizing the probability, that means how far it is onto the left. Then I basically considered that how you can basically lay stress on R L only, and then we went in the concept of Chebyshev inequality, considering the distributions are not normal. And in the last case, we consider that we try to push RP, which is the portfolio of the project, as far as to the right, and based on that we can basically finish our work accordingly. So, again continuing this R value. So, what here is that in this case, in the last to last graph, we were moving RL parallel. So, it becomes a tangent at a particular P star value. Now, in this case, what we are trying to do, we are trying to increase the tan of this angle. So, if consider this. So, this is theta, this is theta 1. So, what we are trying to do, we are trying to just see the pen marker I am moving. So, I am trying to basically move it anti-clockwise till it is basically tangent to this point. So, I have not been able to draw it, but till it is tangent. So, what I try to do is the tan of this angle would basically be the height divided by the base and I try to maximize that. So, if I see how the value comes, this value will be RP, this value is given as RL or RF. So, this difference is given by RP minus RL and this base is given by sigma p. So, if I put in the formula, this value is RP bar minus RL by sigma p. So, sigma p, RL and RP are in the formulation such that trying to basically increase the tan of that angle also gives me the same concept in a different way, trying to basically maximize and use the concept of safety first principle. So, you are the owner of this company manufacturing shoes. I will take extra another 1 or 2 minutes and try to wrap up decision analysis. You are the owner of a company manufacturing shoes and the company has been in expansion phase, and you have 3 cities in India, namely Calcutta, Bhubaneswar, Ranchi. You know that from an amount of investment M W, your utility function is quadratic. For Bhubaneswar it is some other quadratic function, for Ranchi it is another quadratic utility function. If you try to utilize that concept, you will be using the quadratic utility functions with different parameters. Parameters are minus 0.5, minus 0.75 and minus 1 for 3 different cities, and then basically multiply those utility with the corresponding probabilities and try to find out the best equivalence for the expected value. So, the proportions of the total investments are given A, B, C, and the cities are 40%, 40%, 20%. The arms in say for example, Calcutta, in Bhubaneswar it is 30, 30, 40, in Ranchi it is 20, 40, 50. The probabilities of the outcome from historical data for A, B cities in the 3 cities are given 10, 20, 70, second is 50, 40, 10 and third is 1/3, 1/3, 1/3. Based on that we can do the calculations accordingly. With this I will end this lecture for the utility analysis and then start of the concept of project management again, and then slowly see how the concept of utility analysis and project management can be utilized. So, I will also do some problems later on for the safety first principle. So, I will just request the students to have patience and we will definitely do these problems as we proceed with the class. Thank you very much.